Hello children, welcome to AIMS India's online classes. In today's video, from mathematics subject, algebraic expressions topic we are going to discuss. So let's start with the fundamental concepts, children. Fundamental concepts. So what is a constant? What is a constant? So constant, it is a symbol which is having a fixed value. We can use that symbol in any kind of equation, but everywhere if it has a fixed value, then it is called as a constant. So generally all numerical numbers are called as constants. So for example, plus 5, minus 4, 7/3, this is positive integer, negative integer, fraction. These are all belongs to constants, because in an equation x plus 5 equals to 7, the 5 value always it will be 5 only. It does not changes. Even the 7 value also 7 only. It does not changes. According to the equation, we can keep it anywhere, we can take it anywhere. Its value always remains same. So that's why it is called as a constant. So generally, numerical numbers are considered as constants. So next, variable. Variable means a symbol which can be assigned to various values is called a variable. These variables, they are also called as literals. They are also called as literals. So all alphabetical letters, all small alphabetical letters like A, B, C up to X, Y, Z are considered as variables. Means in the place of variable x plus y equal to 7, we can keep any value. We can take 2, 2 plus 5 equal to 7. Then it will become true statement. If we take 3, 3 plus 5 equal to 7, then it will become false statement. The statement may be true, the statement may be false, but x is open for any value. We can take 2 or we can take 3. Here x is called variable, or it is also called as literal. Not only x, we can denote with small l, small m, small n. With any small alphabetical letter, we can denote the variable. So for example, we know that area of rectangle. So what is rectangle? Rectangle means it will be having 2 dimensions. Opposite sides are equal. Opposite sides are equal and parallel. So one dimension will be length, then its opposite side also will be length. Another dimension will be breadth, then its opposite length also will be breadth. Opposite side also will be breadth, and all angles are right angles. This is an example of rectangle. If you calculate the area of the rectangle, the formula for area of rectangle is length into breadth, where we can take the symbol L for length and we can take the symbol B for breadth. So we can write the formula as L into B in shortcut form. So where this L and B stands for variables, or L and B stands for literals. We can take any value in the place of L, any value in the place of B. Based upon L and B values, the area will change. Area of the rectangle will change. Next, operations on literals and numbers. So since literals represents numbers, so though we are representing it with the X or L or A with any English alphabet letter, but in the place of literal numbers, as we are taking numbers, literals indirectly they are representing numbers. So they obey all the rules of addition, subtraction, multiplication, division, which are applicable to normal numbers. So we will add normal numbers with addition, or we can do subtraction of normal numbers, we can do multiplication, we can do division of normal numbers. In the same way, here literals also indirectly they are representing numbers. So we can add two variables, we can multiply two variables, we can divide them, we can subtract them, we can do all mathematical operations which are possible with numbers, with variables also. With variables also. So here, addition of literals and numbers. So 10 added to x. This is mathematical sentence. 10 added to x can be written as x plus 10 or 10 plus x. Y added to x, it is written as x plus y, or it can also be written as y plus x. Subtraction of literals and numbers. X subtracted from 9. X is subtracted from 9. Means from 9, we have to subtract x. 9 minus x. The mathematical sentence denotes the expression 9 minus x. We cannot write it as x minus 9, which is not equal to 9 minus x. In addition, we can write in any way, but while doing subtraction, as per the given mathematical statement only, we have to write. X is subtracted from 9. Means from 9, we have to subtract x. 9 minus, like 9 minus x only, we have to write the expression. So x decreased by y. Means x less than y. Sorry, x is decreased by y. Means x to x value decreases by y, means from x we have to subtract the y. So x minus y is the correct expression. In this way we can add and subtract the literals and numbers, and their combination we can write as per the meaning of the statement. So multiplication of literals and numbers. So 7 times x. 7 times x is written as 7 into x, which is denoted by 7x. The product of x and y is written as xy. X dot y indirectly means x into y, or we can write as xy. So division of literals and numbers. 10 divided by x. 10 by x. X divided by y. X by y. Like this we can write the combination of literals and numbers using the same rules of mathematical rules of numbers. So here term. So what is a term? So either the numerical or literal or their combination by operation of multiplication is called a term. Is called a term. So when we have, suppose here 5 is there, it is only the numerical, it is a term. Or x is there, it is only a literal, it is also a term. Here 5x is there, it's a product of numerical and literal. Or numerical and literal 5 into x. Numerical and literal, they are combined with multiplication operator. So this 5x will be considered as a term. 2ab. Here also 2 is a numeral, a is a literal, b is a literal. They are combined by multiplication symbol. They are called terms. Next. So algebraic term. So algebraic term means a term of an expression having only literal or numeral with a literal is called an algebraic term. If you take these terms, in 5 we have only numeral. It is a numerical term. It is numerical term because it is having only numerical value. But whereas this x, it is having literal term, it is having combination of both, it is having combination of both, These three are considered as algebraic terms because they are having either only literal or numeral with literal. These types of terms, we call them as algebraic terms. So for example, x, 6y, a to the power of 5, 8ab, these are all algebraic terms because they are having either only literal or numeral with literal. So, numeric term. Numeric term is a term of an expression having no literal. There is no variable, no literal. If such expression, we call it as numeric term, or it is also known as constant term. Like 7, 16, 4, 8, these are all constant terms because they don't have any variable in them. Next. So, in the expression 2x plus 9, this 2x is one term because it's a product of numerical and literal. So, it is considered as one term, and this 9 is considered as second term. So, we have in this expression, we have two terms. They are 2x and 9 combined by plus operator. If there is no plus operator, if there is into, then it will become single term. So, plus or minus are used, plus and minus are used to differentiate the terms. In this expression, we have two terms. Out of two terms, 2x is the algebraic term, 9 is the numerical term. We have a combination of both. Next, powers of a literal. So, if a is any literal and n is any natural number, then a power n. Then a power n means a is repeated n number of times. A is repeated n number of times. If a is multiplied by n number of times, then it is denoted as a to the power of n. Instead of multiplying n number of times, we can denote it as a exponent and can be written as a to the power of n. So where a is called as the base and n is called as exponent or power or index, and a power n is called exponential form of this multiplication. A power n is called exponential form of this multiplication or of this product. So, suppose we have x power 7. Here x is repeated 7 times, or x is multiplied 7 times. X is multiplied 7 times. That multiplication or the product, in shortcut, it has been written as x to the power of 7 in exponential form, where x is the base and 7 is the power or exponent or index, which tells how many times the base is multiplied repeatedly by the same number. Suppose a power 5 is there, it is read as rise a is or a rise to the power of 5. A rise to the power of 5. Or x power 1 is there, x rise to the power of 1. Means only one time we have x. So which is equal to x. Or x power 0 is there, x rise to the power of 0. Means no x. Nothing but 1. So any base rise to the power of 0, its value will be 1. In the base place, we may have negative number, or we can have positive number, or we can have root 2 number, or we can have fraction. We can have any number, but if in the exponent place, if we have 0, then its value will be ultimately 1. Ultimately, its value is 1. One minute. 1 minute, children. Next, like and unlike terms. So the terms which contain the same literal factors are called like terms or similar terms. In the term, if the literal factors are same, then they are called like terms. For example, we have some terms here. One is 6ab, another one is minus 3ab, another one is ab. If it is written as factors, 6ab can be written as 6 into a into b, minus 3ab can be written as minus 3 into a into b, ab can be written as a into b. Here, 6 is one factor, a is one factor, b is one factor. Here minus 3 ab, here ab. Here 6 is the numerical factor, ab are the literal factors. Here also ab are the literal factors. Here also ab are the literal factors. The literal factors are same in all the terms, so they are considered as like terms, or we can also call them as similar terms. Suppose if you have like this 6ab, 7abc, 8xy, like this. In this, here literal factors are ab, here abc, here xy. Means they have different literal factors. So they are considered as unlike terms. Means they do not have same literal factors. So they are called unlike terms. So 5a, 5a square, 5ab. These are unlike terms. Because here literal factor a is only one time. In the second one, a square means a into a, 2 times. In the third one, a into b. The literal factors are different in 3 terms, so they are unlike terms. So 2 or more terms having same literal factors are like terms. In like terms, the numerical coefficient may be different. In 6ab, the numerical coefficient is 6. In minus 3ab, minus 3. In ab, there is no numerical coefficient, means we can take it as 1. All the numerical coefficients are different in like terms. There is no compulsion that they should be same. Only the literal factors to be same, not the coefficients. Next one. Next about factor. So in a product, each of the literal or numerical value is called a factor of the product. Or when numbers and literals are multiplied to form a product, then each quantity which is used, or each number or each literal which are involved or which are multiplied for making the product, that quantities are called factors of the product. Suppose if the factor is numerical or constant, then it is called numerical factor. Or if it is variable, then it is called literal factor. Suppose we have a number 12. How can we form the number 12? By multiplying with 3 and 4. Actually, we have so many combinations. 1 into 12 we can write, 2 into 6 we can write, 3 into 4 we can write. If we take the product of 3 into 4, what does it mean? 12. The product 12 is made up of 2 quantities. One is 3, another one is 4. These 3, 4 are called factors of 12. So 12 is made up of, 12 is a product which is made up of 2 quantities, 3 and 4. So 3 and 4 are called factors of 12. But both are constants, so we call them as numerical factors. Suppose if we have 6xy, 6 can be written as 2 into 3. Xy can be written as x into y. So here the product of the 6xy is a product which depends on the quantities 2, 3, x, y. So this 2, 3, x, y, these 4 quantities are considered as factors of 6xy. Out of 4 quantities, 2, 3 are numerical factors and xy are literal factors. In minus 3xy is a product made up of minus 3 and x and y, made up of quantities minus 3, x and y, where minus 3 is a numerical factor, x, y are literal factors, or x is a literal factor, y is a literal factor, or the combination of xy, x into y is also a factor of minus 3xy. So we can take individual quantities or we can take common quantity. These are all literal factors of minus 3xy. Next one, we have coefficient. So any of the factors of a term is called the coefficient of the product of the other factor. Or let's see another definition. In a product containing 2 or more than 2 factors, suppose we have 18, 2 into, or we have 24, we can write it as 2 into 3 into 4. We can write it as 2 into 3 into 4. So 24 is a product having the quantities 2, 3, 4. So it is having 3 factors. One is 2, another one is 3, another one is 4. Here 2 is called coefficient of other 2 factors. Suppose if we take 2, 2 is the coefficient of product of other 2 factors, because we can write it as 2 into 12. 2 is the coefficient of 12. Or if we can take 3 outside, 2 into 4, 8. 3 is the coefficient of 8. Or if we take 4 single, we multiply 2 into 3, 6. 4 is the coefficient of 6. But normally, these coefficients are used for the literals. Suppose we have minus 5xy cube. The numerical coefficient is minus 5. Literal coefficient is xy cube. Suppose if you want coefficient of x, if you want only the coefficient of x, then remaining part in the term will act like coefficient of x. We want to tell coefficient of x. So if we exclude x, what will be the remaining part? Minus 5y cube. So minus 5y cube will be the coefficient of x. Suppose if you want coefficient of y cube, then what will be the remaining part? Minus 5x. So coefficient of y cube will be minus 5x. Like that, according to the requirement, we can have the coefficients. So in 7xy, so 7 is the numerical coefficient of xy. 7 is the numerical coefficient of xy. Or x is the literal coefficient of 7y. Because in 7xy, if we separate x, what will be remaining? 7y. What does it mean? X is the literal coefficient of 7y. Or if we separate y, what will remain? 7x. Y is the literal coefficient of 7x. Or if separate x, what will remain? xy. 7 is the numerical coefficient of xy. Like that, based on our requirement, we can take the coefficients. Suppose if we have AB, there is no numerical number in front of AB. So at that time, we have to consider it as 1 into AB. So 1 is the numerical coefficient of AB. Or minus xy, we can write it as minus 1 into xy. This minus can be written as, if there is no numerical coefficient, we can write it as 1 and minus is there. We can write it as minus 1 into xy. Then minus 1 will be the numerical coefficient of xy. So when there is a minus 1 AB plus 1 AB, if we have expressions like this, no need to mention 1 here. We can simply write minus AB or plus AB, because if there is no numerical coefficient, we have to assume there is 1. So no need to specially mention that 1 there. So okay, children. So in today's class, we learnt about fundamental concepts like constant, variable, operations with the letters and numbers. Next, multiplication of letters and numbers, division. Next, what is a term? What is an algebraic term? What is numerical term? What are parts of literal, like and unlike terms? And what is a factor? What is coefficient? Up to these concepts we have covered, children. So next concepts we can learn in our next video. One minute, children. So that's all for today, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. You can also visit our website aimstoday.in for information regarding online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.